SQL is a standardized language that was developed for interacting with relational databases. It's either pronounced SQL, like I like to do, or a lot of people pronounce it SQL. They're interchangeable terms. And it's pretty much assumed when you're talking about a relational database that SQL is the language that is used to manage the data and the structures, the things inside of that database. SQL is a very standardized language, and it was developed expressly for managing databases or managing RDBMS systems. And because it was developed expressly for that purpose, it separates itself from what I'll consider traditional programming languages, things like C or Java or Python. Those languages are generally procedural, and a procedural language means each line of code is executed one after the other, right? It just walks down the line. If you type 10 lines of code, the interpreter or the compiler executes each one of those lines of code in order, starting with 1 and 2, then 3, and just like that until it reaches the end of the code. SQL, on the other hand, is mostly, although importantly not entirely, a declarative language. And this is a pretty esoteric description of functional languages and declarative languages and procedural languages. But the point here is that SQL is kind of interpreted holistically, the entire SQL statement. I've got an example of an SQL statement right here. And don't worry if you're brand new to SQL. It's meant to be fairly easy to understand, fairly legible for simple SQL statements. And you don't really need to know how this works, but you can look at it and I think you can figure it out. We're going to update something called scores. We're going to set the home score to 35, the away score to 17, but only where the game number equals 22. So I only want to update one game with this particular score. If this were a procedural language, the first thing they would do is it would say, okay, we're updating scores. All right, set every score to home 35, away 17, and wait, I wasn't supposed to do it to every score, just this one particular game score. So interpreting this command procedurally would be a problem, whereas SQL, this command is interpreted holistically. The entire command is looked at, and so the database engine, the SQL engine, is going to look at this and say, I already know that I need a limit to game number 22, and it will never make the mistake of updating every game in the scores table with that score. So it will look at and understand the entire language. Effectively, we are telling the SQL engine or the database engine what we want to do. We're not telling it how to do it. We're letting the SQL engine handle that itself. We're simply telling it what we want to do, and the how is really unimportant to us. And that statement that we just looked at, by the way, more or less conformed to the American National Standard Institute definition of SQL. There is actually an ANSI SQL, which is, you can think of the formal SQL, the real, I'm making air quotes with my fingers there, SQL. Unfortunately, every RDBMS implements its own variation of ANSI SQL. It's kind of like dialects of a language. So every RDBMS system, whether it's Microsoft SQL Server, MySQL, or yes, Oracle, has its own little nuances, its own little tweaks, its own little variations from ANSI SQL that make it unique to that system. And there's a lot of different reasons that they do this. Not really worth getting into. You should just understand that knowing ANSI SQL is kind of the beginning, is the start. And if you know ANSI SQL, you're going to be able to read and recognize SQL from any of these systems. But being able to write SQL that works accurately in those systems is always going to require some specialized knowledge. Just like being able to speak Southern American English is different than Northern American English. But you'll probably be able to understand anyone who is speaking either dialect if you know English, as long as you know English. Another important thing to understand about SQL is that it is intended to be written and then handed off to the database engine or the SQL engine to be processed. So you might have an application or a program that compiles and builds this particular SQL statement, and then that application simply passes that statement down to your database engine, and the database engine runs that code. It figures out the most efficient way. Like I talked about before, it's declarative. We describe what we want to do. The database engine handles the how. So it will figure out the fastest and easiest and most efficient way to accomplish what you've described, and then it will do that. It will also hand back data if that's appropriate as well. So a simple SQL statement here called a select statement, because it starts with the word select, is a query. And this query is intended to return data. When you pass this SQL statement over to the engine, you are expecting a response. So whatever program or code you're working with to send this data has to also be programmed to handle a response of data. It has to handle the results. And the results might be 0 records. Maybe nothing matches our game date of 1/1/2/17. Maybe there was just one game that day. We might only get 1 result. Or we might get 2 or 3 or however many results. We're getting a 0 to many set of data in return from a query. And so whatever handles the results of this query has to be able to handle a collection of data that might be empty. It might have one row in it, or it might have 2 or 3 or 5 or 500 rows in it. We never quite know. We have to be prepared for that eventuality. So those are the basic elements of SQL, structured query language, a way to easily and smartly interact with your database files in your database engine. I hope this has been informative for you, and I'd like to thank you for viewing.